Greetings, Earthlings. Well, I've got the replacement parts that I know I need for this Keithley 190. Show you here. There's some quarter amp slow blow fuses, 3 AGs. I got a fuse holder, of which I'm only going to use the cap. Okay, but I just got the whole holder. It turns out you can just buy the caps, but it's not really worth it. And I have a replacement potentiometer with switch, which we'll look at. So I've taken the old potentiometer out, and we can verify once and for certain that the switch is bad by doing this and this. Okay, beeper, okay. That goes there, that goes there. It's on, it's off, it doesn't matter. Yeah. No continuity there in that switch. The new switch, I'll do the same thing. Goes there, whoops, that goes there, that goes there. Oh, it's on already. Off, on, off, on. All right. So that's good. Let's see about the resistance. The old one, these are 500K pots, supposedly. And they're supposed to, I assume linear, but, so that's 512, okay. This one, the new one, whoops. And it's about 20% low. That's kind of marginal, but I think it'll be okay in this circuit. It's just a timing thing. So for the time being, I'm going to go ahead and plug this back in, and I'm going to put a jumper where the switch went. Okay, that's what the clip lead is for. I've got a clip lead here. And I'm then going to plug it into a dim bulb tester, because I still don't know that there isn't a short here, even though I tested what I could and it seemed okay, just to be safe. That's an incandescent light bulb that's just in series with the power line. So if this presents a short circuit, that will light up completely lit up and stay lit up. Otherwise it will go dim, and we'll know that it's not likely to blow a fuse. I said not likely. That doesn't mean it still won't, but so this plugged in. So just to show where I'm at, I've got this connected back up. It's hanging out here where it's not going to touch anything. I've got the I've got a jumper across where the switch goes, so it will be on. I have a power cord. Now what I've done here is I've cut off the ground lead because this is two-pronged. So I'm going to have no safety earth, as it were, and that could be a problem. So I'll have to be careful. I'm going to plug that in. Okay, I'm going to take a fuse. I'm going to take a fuse. This slides this way. Give me one fuse, please. And I said one. Okay, and just verify that this fuse is good without blowing it. Okay, got a good fuse. Into the fuse holder with you. And when I plug this in, we'll watch the light bulb. Okay. Nothing. That's cool. Oh, but look here. We got something. Okay. And this is just the update rate that this sets, I think. So, and this is like an RC time constant. Okay, so we've got, pretty much garbage. Well, let me give it, I've got right here 4.096 volts. So let's see. Okay, look, it's going down towards 0. That's pretty cool. 1.622. Okay. Oh no, there you go. 4.0978. It's actually almost in calibration. This is going to be way too easy. Okay, I'm going to get the new switch installed into the front panel, and we'll run it through the calibration procedures. But look at that. 1, 2, 3, 4, 5. And there's another half digit over there. All right, and here it is with the new switch potentiometer installed. There's the old one. And I've plugged it in directly to the power line. We don't need the dim bulb tester anymore. And I have it now set on resistance, and I have a 10K precision resistor, 0.005%. So let's turn it on and see what we see here. Okay. 10.01. It's pretty close. It's pretty close. Yeah. So it's calibration time. All right, so it's been warming up for 2 hours, which is what the specification is. All I've done is adjust 0, and this thing is in spec, except on the 1,000 volt scales. I've run through the basic checks, and except for, so this is 10 volts in. It's got to be within 20, plus or minus 20 digits. Well, that's pretty close. If I go to 100 volts, let it settle. That's pretty close. If I go to 1,000 volts, let it settle. Okay, that will not get within 20. That's 0.52. So you see that's off. And on AC volts, you get a similar. Well, no, it's not really similar. Okay, I'm back to 10 volts now. DC. Yeah, see 10. Okay. If I zero it out here, it should be, you should see close to 0. I use this shorting bar, but you can see it's pretty darn close. Okay. AC volts. Let's look at AC volts. I've got 1 volt, and I'm putting it out at 100 hertz. So, and the spec is plus or minus 360 digits. Well, that's within 67 digits, 70, call it 70 digits. That's in spec. 10 volts. Out of range. 10 volts. Whoops. Let's see. 360. This is 132. Counts off, so that's in spec. I'd like it to be closer, but it's in spec. going to the 100 volt range. There's 10 volts, 100 volts. Operate. And okay, 176 counts. That's still within 360 counts. 175. On the 1000 volt, I cannot go to anything over 110 volts with this. It's set to 110. Well, I can go to 1199999. That's 110. So on the 1000 volt scale, it's putting 110 in, and you can see, well, that's way off. It wants me to put it at 400, and I just can't give it 400. But 110, 111. You did see that one change. Go back to 110. Yeah. So anyway, it hardly it's hardly worth really doing an adjustment, I think, here. I'm going to do it just because, like I said, I like it closer than what we're seeing here. All right, and at this point, I'm going to declare victory. I calibrated it, ran it through the full calibration, off camera, and here we are, DC volts. It's actually off by 2 counts here. I have the Fluke 343A set to 1.23458 instead of 56, so off by 2 counts. Hey, that's close enough. Let's go to the 10 volt scale, see how that looks, and let it settle in. And we were 5. Oh, and that's 8. Okay, so there's 1, 2, 3, 4, 5, 6. That's spot on, or 12.3456. That scale is bang on. Good. Let's go to the 100 volt scale. 1, 2, 3. Well, that's okay. There we go. That's off by 3 counts. 7, 8, 9. Three and a half counts. Oh no, there it is. 3. Yeah. Okay. I got 1, 2, 3.459 there, so that's 3 counts. That's good enough, don't you think? Let's go to like 1,000 volts. Oh wait, ooh. Okay, 1,000 volts. 1,000 volts. There we go. Call that close enough. There. It settles in. Okay, I'm starting to wonder about this thing, how long it takes to settle, and why the reading rate is adjustable. I guess it's so you don't annoy yourself with the blinking there. Okay, there you go. Resistance is futile. No. I shouldn't do that with 1,000 volts hanging out on that. Okay, K ohms, 1K. Okay, here we go. Now, this is where it's set to 0. Okay, so there's residual resistance in the switches. The switches probably could use another cleaning, another shot of deoxit. But the switches and the leads. Okay, so we got a 00062, right? If I put 1K in, Okay. You know, it's pretty close. This is not actually adjustable. There's no calibration controls for resistance. It's just based on the DC voltage calibration. So call that close enough. 10K. Again, back at 0. There you go, 0.0008. There's 10K. And we wait, and we wait. And yeah, that's pretty good. Go to 100K. That's what 0 looks. This is what 0 looks like on the 100K scale. There's 100K. Let's give it another shot here. Oh, come on. You can do better than that, can't you? Can't you? Maybe not. Still, that looks a lot like 100K. And let's go to 1 meg. That's 0 on the, well, that's 0 on the 1 meg scale. Okay, there's 1 meg in. Yeah. Yeah. Let me try 10 meg. 10 meg, you press this in. These all pop out. So there's 10 meg ohms. And then this says 10 meg. Try again. Whatever. It's there, you know, it's close enough for all practical purposes. Let's try 1 meg over here. This is a 1 meg resistor. Yeah. If I press this, that goes back to 1 meg. Yeah. So, you know, there's all these uncertainties, temperature and the standards I'm using are not, you know, perfectly accurate. In fact, this is like 1 meg, 0.05%. Okay. You know, there's inaccuracies in the device as well, so all that seems reasonable. And we can just quickly look at AC voltage. Notice no current measurement on this. If you wanted to measure current, you would get some current shunts and use them. Okay. Current shunts, like, you know, remember that, where did it go? 0.1 ohm resistor I made. No, I don't see it here. It's here somewhere. Anyway, this is 100 millivolts. Hello, that doesn't look right. This is supposed to be 100 millivolts. Oh, let me turn it on. Okay. 100 millivolts at 400 hertz. Okay. Not great accuracy on the AC. Let me go to 1 volt. This should be a little better. Yeah, I'll take that. 10 volts. Operate. Oh, right. 10 volts. close enough. And so, and then I could go to this is at 10 kilohertz. Okay. 10 volts. And so it's still, it's, you know, it's marginal. I did make an adjustment for that. I thought I had it closer than that. But it's good enough for my purposes. Alright, so there you have it. A stack of Keithleys, all measuring 10 volts and all giving different readings. This guy seems to have slipped out of calibration. I don't know why. I did have to recalibrate it once already. It doesn't. It seems to be forgetting. So I don't know if there's some other problem with it. Yeah, this is no longer reading 10. Whatever. Anyway, I think that's enough Keithleys for me, and I think that's probably enough Nixie tubes.